Hello everyone, welcome to my channel Bytes of AI, and today I'll deep dive into the RAG implementation. Before I deep dive, I'll give you a demo of my personal assistant based on RAG implementation, and also I'll slightly recap the RAG architecture which I covered in the earlier session, and then straight away jump into the RAG implementation. So let's start with the demo. So this is my personal assistant, and what I'll do, I'll load two PDF files and then I'll ask my assistant to help with some of the queries which I have. So I'll select these two files and then I'll upload this one. Do you want to delete previously uploaded files? Yeah, this will be a fresh load and it is deleting previously uploaded files, and then it will upload the new files. It will take some time because uh, in the process it converts the unstructured PDFs to numerical representation of the vector, multidimensional vectors, and which finally get loaded into the vector database. So it will take some time. While it gets loaded, I'll give a brief description of those two papers which I just loaded. So this is the famous paper, Attention is All You Need. This brought the breakthrough changes in the language model by introducing the transformer architecture. And so I'll ask one random question from here. And there is another file that is, it's kinds of provides a syllabus of GCSE physics. This is almost 57 pages, so I don't want to go through that entire pages. I just will ask some specific information from that. Let me check whether it has uploaded or not. Okay, now it's showing that upload is successful. Let me ask the questions. So it has thought about and then saying the topics. You can see that the GCSE physics topics covered by OCR board as outlined, and it says that matter, then again force, and all the details means topics and subtopics. So let me ask them very precise questions. What are the topics or subtopics included in force? So it has given very details now, as mentioned in the source document page 2. See, it is mentioning the page 2 as well as a source document. So how does it help? I'm not satisfied with this answer, let's say, and I want to get some more details. If that is there, then I'll open the document, I'll go to the page number 2 and I'll find out some more details. So that's how my assistant helps me. And let me check how does it help able to answer from the next document as well. What is positional encoding? See, it has taken that answer from that attention paper, and also it has given the page number here as well, that page number 2. It has given some mathematical equation. You can see here that it uh, took that those two equations from this document. So I'll just log out from here. Content has been built using the React, and backend has been built using Django. And Django has the React pipeline implementation, which I'll go in few minutes. So before that, before I deep dive into the RAG implementation, I just want to recap the RAG architecture. So RAG architecture, you have a document store where you get uh, continuous updates from all different documents, or you add your documents into document store, and and there is a process which actually embedding model, and that embedding model actually converts those unstructured PDF from document store and converts to multidimensional vectors, which finally get stored into the vector database. And when users search a query, user submit a query, then at that point, vector database search for the closest match using the similarity search algorithm like Euclidean distance and quotient similarity, and returns closest matches. And that those closest matches are fed to large language model, and finally large language model do its magic by generating very understandable responses and send it back to the user. So this is very briefly the RAG architecture. Next, I'll go to the implementation part. Let's start with the implementation. So uh, I have used for Visual Studio Code to implement this, and uh, any kind of implementation, I'll suggest that use a virtual environment. So here I have already created a virtual environment. I'll just initiate that, activate that. To implement this particular solution, uh, you have to actually create a requirement.txt file, and with that, where you can specify the what are the packages you require. So here I have mentioned that to require packages. You can see that dot environment packages is required to load the environment variables. Then ChromaDB is to load the Chroma database related packages. Then uh, their PyPDF is to load the PDF data and extract from them. And also there are a few LangChain wrapper is there related to Hugging Face, OpenAI, Chroma. So Hugging Face embedding model I'm using. So for that it is used an OpenAI large language model I'm using. For that LangChain OpenAI wrapper I'm using, and then LangChain Chroma to interact with the Chroma vector database. And you need a few environment variables as well, like here PDF directory to store your PDF files, and then vector database directory to create or store the vector database. Then OpenAI API key actually used to call the large language model. Then client type is Chroma here, and Chroma collection name is my doc collection I have defined. You can think of collection name or collection as kind of bunch of similar set of documents which you are storing in a specific place. So anytime you want to access those similar documents, you can just mention that collection name and you can get those similar documents. So there are two main files. One is doc extractor file, and another is rag class loader file. So rag class loader file, here I have actually created a class doc loader which have very friendly functions, which creates the vector database, then interacts with the vector database, like it takes your query and then search the similar matches and return the closest matched to documents, and which in turn sent to the large language model to generate a response. So it is mainly the class which interacts with the vector database, starting from creation, deletion, modification, etc. And doc extractor by is the lineage actually which you can think of starting from defining a lot of variables, then including embedding functions, then uh, interacting with the large language model, and finally interacting with that doc class loader which I just now said, and then finally getting the answers back and printing that response here. So what I'll do, I'll go through this particular file, and as and when it will interact with the doc loader, I'll go back to the doc loader class and try to explain there. You can see that whatever packages I have I have installed here, just to say here, you can, if you do not know how to install this thing, then you can just fire this command pip install uh, -r requirement text. If you just run this command, it will install all the packages. And next, okay, I'll go through this particular file. And first thing which I'm doing, I'm loading my environment variables from this environment file. Then I'm defining a couple of variables. One of them is like chunk size and chunk overlap. So chunk size is when you extract from your PDF, you define a chunk size, like this would be the size of every chunks from that PDF. So here it is 1,000 characters, and chunk overlap is 100. So uh, why chunk overlap is important? It is because it preserves the context between your previous chunk to the next chunk. Then this is the model name for the Hugging Face embedding model. Sentence transformers is a very popular one. This will help us to convert from unstructured document to multidimensional vectors. And how do you call the Hugging Face embedding model? You have to provide the model name, and you have to also provide the CPU or device which you are using. Rather, if you are using GPU, you can mention here CUDA. I have used here CPU, so I have just mentioned CPU. And this is also one of the important one, normalize embeddings. And I have mentioned it is as false. The main reason because I have kept it false because I don't want my embeddings to be normalized. And why it is that? Because Chroma database by default use Euclidean distance to do the similarity search, and Euclidean distance when I'm using that use the magnitude. But and that's why if I required that to be false, because if I do normalize the embeddings, then the magnitude will be normalized, which doesn't make sense if I'm using Euclidean distance. So that's the reason I have kept it false. And then collection name, as I mentioned, I have already defined in the environment variable, which I'm calling here. Then here I'm just using my docloader class, which has been defined here. I'm initiating the docloader class here by providing uh, name of the directory where PDF will be stored, then client type, which is Chroma here, vector database directory, where actually vector database will get generated, then collection name, chunk size, and chunk overlap, and embedding function, which I have just defined here. That's how I'm initiating my docloader class, and I am also initiating my large language model with the chat OpenAI function. And here you can see that I'm calling GPT-4o mini model of OpenAI with the temperature variable set to 0, so that I don't want any creative answer from the large language model. Here I have included a couple of vector store operation, which I'll show you in the presentation. Uh, so one of them is create update vector store. So this is calling one of the function from docloader class, create update vector store. So it will create the vector store for the first time, and then I'll try with deletion of one of the vector, and I'll try also addition of one of the PDF file. And this is important retriever, because this is kind of, you can think of an API which helps me in searching the document. So uh, it takes the query from me, and then it search the vector database for the closest match, and it returns the closest match. And I was playing with a few queries, so those are here. I'll try one of them. And this is a system prompt. This is very important because this is argument for uh, or prompt generation. So you must have heard probably that prompt engineering is a new term in the engineering field. So you have to actually give instruction to your large language model. How do you want to get the response? So that's what I have defined here. Like, please include all details from the context. Please provide the source at the end of the reference. And if you do not get the answer from context, say you don't know. And context is what, if you go back to my earlier session, then you will understand that context is kind of the closest match which we are getting by querying the vector database. And prompt variable is actually using one of the function from chat prompt template, and it requires two argument. It is like system prompt and human input. Human input is nothing but the query which I'll uh, supply here. And then question answer chain and message variable, these are important in the sense that question answer chain is first. So create staff documents chain and create retrieval chain, both of them returns the runnable type. Runnable type means you provide, so initially when it takes the argument, it doesn't get executed unless it is invoked by some query. So create staff documents chain is taking argument LLM and prompt. LLM is, if you remember, I have defined here, that is actually the large language model, and prompt is here what is defined. So prompt do not have the information yet, because prompt do not have the context, right? Which I have which is the result actually retrieved from the vector database. And then I am using create retrieval chain function, and which uses retriever, which I told you earlier that it kinds of help me in querying the vector database. And it also takes another argument, question answer chain, which I have defined here. So question answer chain will provide the prompt will contain the context. So the output of retriever will be fed into question answer chain, where in prompt and in context. So this way the chain gets defined, and then you have to invoke that chain with the query. So query which I have defined here, what is positional encoding. So this is the query which will get invoked, and message will have two parts. Message is kind of a dictionary inputs, so it will have the context, also the answer. So I have not printed the context here because context will look a mess. So just I have printed your answer. So this is the chain which I'll just run in a minute. And before that, I just want to give a quick walkthrough of the dockloader class and its associated functions. So I have told you how to initiate the dockloader class. So these are the important variables, and then there is a get client function which actually call the persistent client function of the Chroma database. So persistent client is important here because uh, there are, so sometimes you can define a client, Chroma client, without even mentioning the persistent store, because you can just use your RAM, and once you close your system, your RAM will be wiped out, your data will be get lost. So here I didn't want to do that, because in a real application you want to store your data, so the next time when you come back again and you want to use your vector database, you want to retrieve from your stored memory or stored database. So that's why the importance of persistent client. And here you can see that vector database path which I have mentioned in environment files, that is mentioned here, and it will kind of give you a return one client, so that you can use that to create your vector store. And this is a text splitter functions. You can see that I have used the recursive character text splitter. It is again coming from LangChain, and it split your documents in in hierarchical manner. So let's say that that hierarchy you can define. So let's say that first hierarchy is double written character, then second hierarchy is a single written character, third hierarchy is kind of space, and so on. So there are some default hierarchy already defined here, but you can also change the default hierarchy. And this is the get LangChain embedding, and this create LangChain embedding is a adapter from Chroma database. So I told you that there is I'm using the LangChain here as an kind of wrapper. So uh, what Chroma utilities do, or this particular function do, it takes your embedding function, which I have defined in extractor with the Hugging Face model. So it will take that input, it will convert into into a format which LangChain understands. So that's why the create LangChain embedding function is important here. And then finally uh, doc reader function. This is the important one here, because it actually use that PyPDF loader, which I told you that in requirement that it comes from PyPDF. So it use the PyPDF loader to load the PDF, and it returns the documents. Is kind of, so it's again a LangChain class type. So it's a list of documents, and which is finally used in create update vector store. If you remember, I have used this to create the vector store, doc create update vector store. So this is where actually it calls the text splitter. So we get a text splitter object here, and that object use the split documents, and that split documents call the doc reader class, and it gets the list of documents which I am naming as a chunked documents. That particular chunk documents is used in this particular function. This is the important function, chroma.from documents, because this takes these parameters like chunk documents, then uh, embedding function, then collection name, and finally that persistent client which I showed you a few minutes back. And with taking these many parameters, it creates the vector store. I have just given a print statement to check whether how many chunk documents is getting loaded. And this is the get retriever. This is actually returning the retriever of for that particular vector store. Uh, and this is another function which I've defined. This is del source file. That means, like, if you specify a source file, uh, then it will find out that particular source file from your vector database, and it will delete all the trace of that file. And how does it do? It first check the get collection. It take the collection name, and from that collection it tries to get the metadata, and within the metadata it search for all the source files, which is here I have printed, like, all the PDF files present in that metadata before deleting one of them. And finally it calls the collection.delete, and where source is the PDF file which I am providing, and it deletes that particular trace of that particular file from the vector database. So this is all about this particular class which I have defined here. Now I'll just run this and I'll give you demo. So first thing is that uh, I want to create a vector database, and it will take the question what is positional encoding. So here again I have used the same two files which I showed you in the demo of my personal assistant. So I have used the same two files here, but I'll ask mainly the question from the attention paper. So it will take the course, it will create the vector database here, then it will take the retriever to search in that particular vector database, and then it will define the system prompt, and finally it will invoke that with the query defined here, and it will print the message. So let's run that. It will take a minute maybe or less than that. Let's check. We'll first get the message like these many chunks have been added to vector database, and after that we'll see an answer. So 166 chunks to the ChromaDB. This is the answer. So you can see that it has clearly mentioned positional encoding is a technique used in neural network, and it has tried to give the equation as well, mathematical formula, but it is not properly formatted, but definitely this is the answer. So after this, I'll quickly show you other functionalities as well. So now this has created the vector database, and it doesn't need to create again. So I want to just test whether it can delete this attention paper from the vector database. Uh, so expectation is that it will delete the attention paper.pdf, but before deleting it will print out the two PDFs which I have uploaded into the vector database, and after that it will delete attention paper, and then it will try to execute the query for this particular one, what is positional encoding, and I am not expecting any response this time. Let's check. So here again it will print out, see, uh, this is the response. If you, I'm not sure whether this will be properly visible or not, but I'm highlighting. So printing the PDF names extracted from metadata before deleting one of them, and you can see these are the two PDF which I uploaded. One is OSHA GCSE physics syllabus and another one attention paper.pdf, and I have deleted that paper, that particular PDF now, and that's why it is not able to find any trace, and it is answering back like I don't know, which I have mentioned here, right? If you don't get the answer from the context, say you don't know, and it is actually working in that way. And next thing which I'll show you, that I'll try to add that particular PDF back. So this is where actually I'm providing the name of the PDF which I want to add into vector database. So I'm adding that PDF back to vector database, and I'll run that. Let me clear the screen and run the process again. Let me save this file first before running. So I'll run it again. So expectation is here, it will add the attention paper.pdf, and it will give the response back to these questions. So 49 chunks added to Chroma database, and so that means it has been added. Yeah, and it giving the answer along with the mathematical equations. So this is the beauty of the RAG pipeline. It's like your LLM model have not been trained on your personal data, but now you want to build your own application, and where you want to feed your personal data, and you can use that for your own convenient. So this is the end of the implementation demo, and uh, my plan is next to cover details about vector embeddings and exploration around, and probably I'll cover Chroma database in more detail in a later session. So if you like this particular session, then please like, subscribe and comment, and also don't forget to give some inputs for the future topics which might be relevant for you. Thank you.